Hi, it's Richard here from Intelligent Advisor IT Consulting with another of our online modules for intelligentadvisor.com. This module is all about temporal reasoning, and temporal reasoning is a key subject for Intelligent Advisor implementers, but it's also a subject that is shrouded in mystery, shrouded in concern over its complexity and its raison d'être. So, as well as giving you some practical help and giving you some examples and showing you some videos and demonstrating how this works, the goal is also to kind of demystify it all and make it easier to approach when you are not sure whether you need to do it or not. Basically, help you out in as many ways as possible. So, let's look at the agenda. The agenda is really a series of steps. The first side is a lot of practical stuff, learning about what is it for, what can I do with it, what can I not do with it, how should I start when working with temporal reasoning, which is basically a set of examples which start really simple and get a little more complicated. We talk about the concept of temporal data. Temporal reasoning is one thing. Temporal reasoning is writing rules that use temporal data, but in order to do that, we need to understand what temporal data is and how do we get it. And once we've got it, now what do we do? What are the kind of things that people might want to do with temporal data? Again, these are examples, and the zip files are available for download if you've purchased this module. Just look in the lesson attachments and you'll find them. How can I display and how can I collect temporal data? These are short pieces to end with, just discussing, well, if you're in an interview, how can I display and collect it? Okay, big picture first. What is temporal reasoning for? Well, temporal reasoning. What does temporal mean? Temporal means it's changing over time. Lots of things in our world change over time. A classic example would be if I ask you your age today, you give me the correct answer. Next year, I ask you the same question, but you give me a different answer. So, in a situation where you're talking about eligibility or you're making calculations, if your age has an impact on your eligibility, then clearly what was true today is no longer true tomorrow or next year. And this is the basic challenge, is both the answers you gave me today and next year, they're correct at the point in time of the question being asked. And it's super important to be able to work with data like that because you're asking, as I say, to calculate things based on the age of the citizen. And maybe you're not eligible for a discount until you're 65 years old. Next year, you'll be 65. This year, you're 64. If someone, these are common things that come up. So, what is it for? If you were to receive an amount of money every day from your state, from age 18 to 21, and the amount of money depends on the number of children that the citizen has, we would need to manage the age of the citizen, because you're only eligible between 18 and 21, and also the number of children in our calculations, if we say that the amount of benefit you get is dependent on the number of children. So both can and will change over time. If you then add another criteria, such as the money is only provided on weekdays or the amount is reduced by 15% if you're aged over 35, then it gets very complicated to imagine how to do it with traditional data and rules. So these are the two basic problems that we're trying to solve. Values of an attribute can change over time. How old are you? What's your job title? How much money do you have? These values will change. And then the second problem is values used in rules can change and affect outcomes. Let's say that we calculate something based on a percentage that is set by the state government. The state government changes its mind, and on the 1st of January 2021, the tax-free allowance changes. That means that you have to be able to handle that in your rule. A scale or a coefficient, the total weight of fish that you're allowed to catch is 0.75% of your body weight, and tomorrow it's 0.65% of your body weight, and so on and so on and so on. So these are the kind of things we're trying to solve. If it's still not clear why I need temporal reasoning and what do I need temporal data for, I like to look at this simple example. It's a bank statement. You can see that I've been withdrawing money out of my account. I want you to imagine that this is a simple entity with two entity instances. So the first line is the first entity instance, the second line is the second entity instance. Notice the dates. I withdrew 100 on the 1st, and I withdrew 50 on the 4th. Those are the only entity instances you have. Now you need to write a rule to find out what your balance was on the 3rd. You don't have any data for the 3rd of January. You only have 2 instances. You and I implicitly know that our balance could be calculated if we knew the starting balance and we knew that you withdrew 100 on the 1st of January. We should be able to calculate what your balance was on the 3rd. In the absence of any information, we should be able to do it. Doing it with traditional entity instances and rules is going to be tough because you don't have that data. What you want to do is essentially take this information and extrapolate a kind of calendar based on it. Sometimes we talk about building chronologies. So you want to build a chronological flow to show you where this was going. And that's what temporal reasoning is all about. And you can see here in this screenshot on this page, down at the bottom on the left-hand side, there's precisely what I was talking about. You can see a number that is chronologically going over time. And you can see that I've entered change points for the value. So on the 15th, it was 88. On the 16th, it was 75. On the 17th, it was 104. I'm not obliged to have consecutive dates. Maybe I have the 15th and then I have the 20th. That's all I have. So what we're seeing here is that if you look at the screenshot on the left-hand side, a traditional attribute, any attribute, you have 2 choices when it comes to entering data. You can either enter a piece of data at the top. You can see that I've entered 100. If that's all you do, you're saying the value of this attribute is 100 today, tomorrow, and forever. When you enter data in the lower part of the screen, in the change points, you're effectively saying the data value changes over time. And when you do both, you're saying, as you can see from my little screenshot right at the bottom, that the initial value is 100, and that value then changes over time based on the change points. So, what can I not do with temporal data? I thought I'd get this one out of the way very quickly because it's not really that relevant to our discussion today. Is there are certain things that don't work with temporal reasoning and temporal data. A couple of examples would be there's no direct way to work with temporal data in the interview extensions API, although at the end we'll talk about how you can get around it. And you cannot do certain combinations of inferred relationships with manually created relationships or temporal values particularly. And there's the link to the documentation if you need it. And the final one is temporal values cannot be mapped out to an external connection. So if you've created temporal values, you need to do something with them before you send them to Salesforce or Service Cloud or Siebel or whatever to turn them into something other than temporal data. And we'll talk about that a little later on. So now comes the first video demonstration of our course. I'm going to play this video now. The video is also available to you in your course package if you want to listen to it individually, but here it comes. So this is our first demo in the temporal reasoning online module. And for this particular demo, not much introduction is required because I've simply created a new project in Intelligent Advisor, and I've created 7 different attributes. I'm not going to use them all in the demo, but I was trying to make a point, is that absolutely anything can be temporal in Intelligent Advisor. Let's take, for example, the text and the number attributes. I'm going to go and debug this. I'll make it full screen. And rather than playing around with the interview, I'm going to go straight to the Data tab. I'm going to reset everything so we have a nice clean debugger in front of us. And I'm going to open up the details for the number. If I type in 100, what I'm essentially saying is the value of this attribute is and always will be 100. It's a non-temporal value. If instead I go to the change points and I add some change points and then I add some data, you'll notice that each change point has a date associated with it. You can change the dates, of course. I'm just using the dates that it's provided as standard by default to make my life easier. So what I've said there is the value of the attribute on each date is as follows. And let's return the value at the top to unknown. So I'm going to click OK now. And I'm going to use the temporal visualization feature to get a good look at what this attribute now is showing me. It's telling me that this attribute is completely unknown until this date. And then it had a value of 100, 90, 80, 70, and 70 is the last recorded date, and the value is considered to be 70 forevermore, or until a new change point is added. If I return to the Data tab, and I place a value in the top part of the screen, let's put 150, there we go, and click OK, what has changed? Now what I'm saying is the value before any of my temporal dates is 150, and then starting with the first change point, here is the new value, here is the new value, and so on and so on. I can do exactly the same with a text attribute. So let's say that I have two change points for this. The first one is red, the second one is blue, and let's say that it was originally black. Okay. And we'll take a look at that in temporal visualization. So now we can see my text value has changed over time as well. And of course, it doesn't have to use the same change points as the previous attribute. It can be any kind of attribute at all. So let's say let's change the date here and say on the 15th, and on the, I'll get there if I can, 16th, let's say that it was true there and false there. And once again, we'll go and have a look in temporal visualization. And now we can see that my Boolean attribute was nothing or unknown until the first change point, then it was true, and now it's false. And you can repeat this process for any kind of data, anytime in Intelligent Advisor. There's nothing special you need to have to make an attribute temporal. You just need to give it change points. So in our first video, basically what we're saying is everything is temporal whether you like it or not. It's there. The functionality is there. You just need to decide to use it. So this is our first demo. So where should I start? This slide was really just to give you some idea of where we're going next. We're going to talk about getting data in a chronological view. Essentially implementing in a more robust or a more professional way what you've just seen, how you can make calculations based on the chronology, how you can aggregate results on the chronology, and how you can make a dynamic scale or a sliding calendar. These are all examples of using temporal reasoning. They're by no means exhaustive. They're just there to help you get started. Writing rules with temporal reasoning is no different to writing rules for any other kind of attribute. In fact, again, I want to reinforce this one more time. When you write a rule, it is inherently already temporally aware in any case. Consider the following rule shown here. How will it behave, whether I'm using temporal or non-temporal? So the amount of benefit received per day equals the number of children multiplied by the benefit amount. So if I have 2 children and the benefit amount is $5, 2 times 5 is 10. I will receive 10 as the amount of benefit per day. But I guess you probably worked out what the problem is that yesterday I had 2 children, next month I will have 3 children. This month the benefit amount has been increased by the government, so I need to take that into account. How do we take that into account in our rule? Let's take a look at the second video in our series. So welcome to the second in our series of demos for the Temporal online learning module. This is Richard from Intelligent Advisor Consulting, IT Consulting. Really, the idea behind this video is very simple. To help you understand that in reality, everything you do in Intelligent Advisor is temporal or isn't temporal. There is no question about is what I've done temporally capable or not. Everything is essentially dealt with temporal reasoning in Intelligent Advisor. And for this, we're going to do a very simple demo. We're going to go over here and take a look at this rule. This is a project with only a couple of attributes in it. You'll see them straight away. Let's zoom in a bit. The amount of benefit received per day equals the number of children multiplied by the benefit amount. So if I have 2 children and the benefit amount is 10, I will receive 20 currency units in benefit. Simple as that. So let's debug. I'll make this full screen so it's easier to see. I'll reset everything and I'll go to the data tab because it's actually easier to do this in the data tab for the time being. The number of children, I'll enter 2. The benefit amount, 15. Therefore, the amount of benefit received per day is 30. So my rule is a typical, simple, numeric rule making a calculation to assign a value to the amount of benefit. So now let's decide that we need to make this temporal because obviously the number of children you have can change over time. So I'll say that actually I started off with 0 children and then I had a first child back in October and I'll say then the value was 1. I'll add another one and we'll make that November the 7th, the value is 2. And let's say that starting today, the value is 3. So now we have a temporal number of children, which means by definition, the amount of benefit has gone temporal because clearly the amount of benefit received is when I had no children, I didn't receive anything at all. And then you'll watch it go up and up and up. Benefit amount is 15. So first child was 15. From this date, I received 30. From this date, I received 45. So let's take it a step further and say, well, that's great, but the benefit amount also changed. The benefit amount was 15 currency units, but actually starting in end of November, it went up to 17 currency units. Which means, of course, that the initial values were the same, but then they started to grow because not only did the number of children grow, but also the number of the amount of benefit grew as well. So in this case, I have now 2 temporal attributes in my rule. And because I have the 2 input elements that are temporal, well, of course, my output is temporal as well. So now I have basically the number of children, the amount of benefit, and let's put them all in temporal. There they are. Everything is temporal now in my project. And I didn't have to do anything other than provide change points. That's the whole idea, is that a rule should behave just as you'd expect it to behave, whether you are writing things with change points and temporal data or simply with static values. So in the previous video, you saw that a rule is temporal even if we don't actually do anything with it. As soon as we do provide temporal values, then it becomes temporal. As a note of good practice, when you're writing rules and you want to show the readers of your Word document that you are working with temporal data, considering adding something like in temporal format to the text of the attribute, so that it makes it easier to search for things that are temporal. It's not a requirement, it's easier to find. Anyway, so let's look at some easy examples of leveraging this whole idea of temporal reasoning. Earlier, we said that an end user of your interview cannot enter data directly in temporal format. It was one of the big restrictions. I said the restriction is you can't enter temporal data. In fact, in a lot of cases, the temporal data probably comes from something else. Let's look at this, what seems to be a challenge, but in fact is entirely just the way things are. Consider you have an entity called the bank account balance, and you already have an entity and have data in that entity. You have instances. Or an entity called the personal circumstance, and you already have instances of the personal circumstance. The point I'm trying to make is that these entity instances can be converted into temporal attributes. So you could ask a user to enter entity instances as normal in a screen with an entity collect, and then you can convert it into a temporal attribute. Or you could load data from Service Cloud and then convert that into a temporal attribute. More often than not, that is the starting point. So normal non-temporal data is the starting point. Let's take a deeper look at that. So here's a table with some personal circumstances in it. Of course, in order to create temporal data, you either need to have start dates and end dates, or at least a start date, or you need to calculate start dates and end dates. The whole point of temporal data is, of temporal values, is they have change points. So whatever you are doing to create your temporal attribute, you're going to need to have dates in it, change points. Those change points could come from entity instances, or they could come from rules that you write, or it could come from a combination of both. Let's take a simple example and say I have an entity here called the personal circumstance, and I have the employment status, and I have a start date and an end date. And you can see that I have created two instances of this entity. There are three functions in this category that let me create a temporal attribute from data like this. Temporal from start date, temporal from end date, and temporal from range. And they all work essentially the same way. You give them a bunch of instances, you give them at least a start date, and then you tell them what data it is that you're interested for your temporal attribute. Because a temporal data needs a change point and a value. So the date and the target level entity attribute that you can see here, the date is the change point date, and the target entity level attribute is the data that you actually want in your temporal attribute. All you need, therefore, to do something like temporal from start date is an entity with some instances and a start date and a value that occurs on the date. The output is a brand new attribute with your temporal values. So here's an example, temporal from start date, the personal circumstances. Notice that the first argument is a relationship, not an entity name. So if typically it'll be a plural. The personal circumstances, the personal circumstance start date, and the personal circumstance. And it will build you an attribute based on that data. So the output of this function will be one new temporal attribute. Same for temporal end date. If all you have is an end date, you can use the same, and I realize that at the top right-hand side it should say temporal from end date, not temporal from start date. That's a copy-paste. All you need is end dates. Or if you're really lucky, and you have both start and end dates, or you can calculate start and end dates, then you can use temporal from range. Temporal from range requires both a start date and an end date. And in each of these three cases, the output is a new attribute. How they handle the information that you give it, so if you give it some personal circumstances from your entity, how they build the attribute and reflect the data that's in your entity depends a little bit on whether you're using temporal from start date, temporal from end date, or temporal from range. And as you can see in my screenshot, it's okay, to begin with at least, if you don't have data that completely matches up. You'll notice I have periods where it is uncertain. You would need either to fill that up with your own rules or with data, but the point is, when you use temporal from range, be aware that you might not have data that all matches up. Let's take a look at how these three functions work in real life. So they all have similar syntax. They need a relationship, one or more dates, and a piece of information to put in the chronology. And there are several different behaviors in the video sequence that is coming up. The key point here is you are able to create a chronological display of information using these functions. That's the starting point for any of the complicated ideas of reasoning or functions based on it. Starting point is get yourself a temporal attribute. So let's take a look at a practical example of that. Welcome to the next video in our series in the temporal learning module. This one is going to focus all about the three functions we've just discussed in the slides: temporal from start date, temporal from end date, and temporal from range. As you'll recall, all three of those functions create a new attribute for us. And they create their attribute from an existing entity and use that information to build a single attribute with change points. So what I've gone ahead and done, as you can see, is I've created a new entity called the personal circumstance with the personal circumstance start date and the personal circumstances as the containment relationship. So now I'm going to switch over to Word and we're going to create our first attribute. So the first example using temporal, I know this is not how I would normally name an attribute, but this will do, using temporal start date equals. I'll put this into conclusion formatting and I'll use the rule assistant to give me a hand. So I'll say TMP, temporal from start date. That's the one I want. I only have one relationship here, so in this project, so I can go ahead and pick it. And the date that I want is the personal circumstance start date, and the value is the personal circumstance. There we go. So it's important to realize that what I've done is I've taken the entity data that's in personal circumstances and I've used it to create a global attribute. So you'll notice that the first example using temporal start date, excuse me, is a global attribute. Let's close the Word file and go ahead and see what's happened in the debugger. I'll reset it and go straight to the Data tab, and my focus therefore needs to be on creating personal circumstances to begin with, because they are the data that is used to create the temporal attribute. So let's say that in the first instance I was unemployed, and the start date of my unemployment was, well, I started work, I joined the active population when I turned 21, and let's say that I turned 21 this time last year, or thereabouts. And then I'll add another personal circumstance and say that I was engaged in some voluntary work, and that started in, let's say, March 15, 2020. And the final one will say that, well, you know, the voluntary work went well, so I got a job. And let's say that I got a job quite recently, in fact. So now I've entered my instances. Let's go and see what's happened over in the global attribute. You'll see that I have a new attribute, the first example using temporal start date. Recall that these three attributes have nothing to do with this example. They're the example from the previous chapter. And we can see that this data is fully temporalized. So we can see that the first example using temporal start date, I was unemployed from this date, starting on this date, because remember the function is called temporal from start date, so it assumed I was using a start date. Then I was engaged in voluntary work, and then I was employed. And I'm still currently employed because there is no future, there's no start date later than this one. Prior to the initial start date, the results are that it is uncertain as to what I was doing because there's no change point data available from the entity instances. Cool. So let's take that a step further. Let's go now and try out the second one, the second example. And the second example will also require me to go ahead and make some changes to my entity model, because I will also need to add a personal circumstance end date, because the idea of this function is it's when you have something which is representing an end date. So I've added my personal circumstance end date. I can go ahead now and create a second example. The second example using temporal end date, and I know that's the wrong name. It should really be temporal from end date and from start date. From end date, let's make it a conclusion, equals. And as before, I'm going to use the rule assistant to help me. So I'll say temporal, and this time it's temporal from end date that I want. The personal circumstances, this time I'm interested in the personal circumstance end date. and I'm interested, as before, in the personal circumstance. There we go, and let's compile that, and let's go ahead and go to the debugger. The important thing in respect of these functions is you choose the function based on the data that you have or the data that you are able to procure. So this second example, which is temporal from end date, by definition, it's going to not look at the start date, it's going to look at the end date because that's the attribute that I gave to the function. But it also means that in order for it to work, you're going to need to give it end dates. So I'm going to go ahead now and give it some end dates. So I'm going to say that the first one ended in, let's say, 2020, March of 2020, March the 15th. The second one ended on in December, and the last one, just to demonstrate, I'm not going to give it an end date right now, and you'll see that when I look at the temporal visualization, the second example doesn't have anything. It doesn't work because it requires me to give end dates for each of my pieces of data. Of course, in my case, I'm entering static end dates, but you could imagine ways that you could calculate an end date if you didn't have one. So let's say today's date, at which point the second example becomes operational. And you can see that I was employed, and then I was unemployed, and then I was voluntary, because I've actually got the dates mixed up when I was entering the end dates, because it's the new year. So I'm going to switch that back to the end date will be today's date, which is 2021. And we'll see now that it's swapped over. Notice the difference in behavior is that the from end date assumes that because I gave it three pieces of information, I was unemployed, voluntary, and unemployed, it assumes that the first one was valid until it hit the first end date. Whereas the obviously from start date said, well, your employment or your personal circumstances started here because that's the start date you gave me. So everything in front of it is uncertain. As far as the temporal from end date is concerned, once the last end date is passed, it is uncertain as to what's happening now because there's no information. So you'll notice, therefore, that the two of them behave logically, but slightly differently based on the fact that one is looking for end dates, one is looking for start dates. Let's take a look at the end date as an example. What I'm going to do is go back to these examples now, go back to these attributes. I'm going to hide the first example from temporal visualization for a moment, and we're going to focus on the temporal from end date. Okay, so we're going to go back to the temporal from end date raw data, which is our three personal circumstances. And remember that the temporal from end date is only looking at the end date. So we're just focusing on the end dates in this example. I've got the 15th of March, I've got the 31st of December, and I've got the 14th of January 2021. So I'm going to go back here and I'm going to change the end date to say that the end date is in fact sometime in, let's say, 2021 0101. Obviously, you'll see that the data has changed itself around to say I was on voluntary work, then I was unemployed, and then I was employed. So changing the source data changes the output of the attribute. But now let's go back to these and say, okay, I want the voluntary end date is 12/31, and I'll say the unemployed end date was 12/31 as well. Now we have a problem because two items in my input, so in my entity instances, shared the same end date, at which point those two have disappeared completely off the chart. And Intelligent Advisor tells me everything else is uncertain apart from the fact that we know that something ended on the 12/31 and my employment ended on today's date. So these functions are very sensitive when you have duplicate end dates or duplicate start dates if you're looking at temporal from start date. So you may need to massage the data in some way, perform calculations to add a day or subtract a day, or in some other way handle this. Now let's go back to our Word document and look at our third and final example of this. The third example using temporal from range. And we'll do as before, switch into the conclusion and go to the rule and rule assistant, temporal from range. Personal circumstances, start date, end date, and it's the personal circumstance that I want. So we've created a third example, and this third example will, hopefully, we can now demonstrate it. We'll refresh the debugger. We'll go back to the data tab and we'll hide temporarily the other two, and we'll make sure the third one is shown. We can see that the third one has successfully displayed the unemployed and voluntary and employed phases, but because it's using both the start date and the end date, its behavior is a little different. You can see that between the voluntary phase and the employed phase, it's saying, well, there's actually a day that I don't know what you were doing. So we can go back to the voluntary data, and you will see that the voluntary ended on the 31st of December, and the employed started on the 1st of January. So in this case, it is interesting to have dates that all line up, because the way it reads the dates, logically enough, start date and end date, means that you're going to, where possible, want to have dates that line up. But obviously, as you saw a moment ago, if you don't have dates that line up, so 2021, 12/31, that's okay. That's okay, because you can have periods during your chronology where the status is uncertain. And you would just need to know that that can potentially exist, and you would need to manage it in your logic, or you would need to adjust dates if appropriate so that there weren't any of these. So these three functions, let's put them all back on the page now, all behave in similar but slightly different ways, and the behavior they have will depend on whether they're reading information as start dates or end dates or both, and whether there are multiple occurrences of the same, for example, the same end date. Okay, so in the previous example, you saw how to create yourself some attributes, some temporal attributes. But now that you've got that, you can see clearly that one of the jobs you're likely to ask yourself is, when was I last employed? When did I last take voluntary work? Or when was my personal circumstance last uncertain? So the first category of functions that you're likely to need are this family. There are two of them, when last and when next. Now that you have your chronology in place, we can start to pull answers out. When last looks backwards. So if you say, when last, 2021, 1st of January, it will rewind your chronology looking backwards through time, looking for something interesting that you've specified. When next, exactly the same concept. You give it a date, so you maybe give it the earliest date. You say, the earliest date in my chronology is the 1st of January 1990. Go forward from that date and find something interesting for me. When next and when last, therefore, are great for pulling out pieces of information that are of interest to you. I also just mentioned now a function called earliest, which is a great way of sending your chronology to the beginning of the calendar, so that you can just say, go to the beginning and find when next something happened. So let's take a look at a video example of how to use where next and where last. So in this section of our video accompaniment to the Temporal online learning module, we're going to kind of answer, or begin to answer, the question, well, what do I do now? You know, you've gone to the trouble of creating a temporal attribute, so what? Well, we're going to start being able to analyze data in a more easy way than we would have done if it had been entity data. So just to recall where we were, we have a few personal circumstances, and now we are able to use 3 different functions to place that data into temporal visualization. Fine. What we're going to do now is we're going to leverage that temporal data and start writing functions, start writing rules that leverage it. I'm going to do this one in 2 parts. The first part is I'm going to create a Boolean, because I am sure we've mentioned in other modules, and I'm sure you've learned, is that quite often having intermediary Booleans is very useful when you want to debug, or also there are certain functions that require you to have Booleans instead of text-based attributes or whatever. So let's put in the data indicates military service if, and I'll put that into conclusion. I'll put this into level 1 and we'll use the rule assistant. The key with these new functions is to remember not to go back to the entity data. The whole point of the previous exercise was to create temporal attributes, and now we're going to be able to use them. So the data indicates military service if, and we'll use the temporal from range, which is the 3rd one, equals, and I seem to recall one of the values military. One of the values was military service. So I've set up, first of all, a Boolean attribute, which, as you can probably tell, is going to be yes, no, depending on whether you're doing military service. So if we go to the debugger and take a look, we will indeed see that we have created a new attribute called the data indicates military service, and we can see that it has 3 change points. So our new Boolean attribute is following along our chronology. Military service, not military service again. So let's take that one step further and say that our goal is to verify your status as of a reference date. So we could say something like first military service after 2001 equals, and we'll do this again with our rule assistant, when next, and we'll say the date is 2001-0101, and the condition is the data indicates military service. So you can see now that we're leveraging our Boolean, which itself was leveraging our temporal attribute, to find out when you did your first military service after 2001. And if we return to our debugger, we'll see that the response is 14 January 2021, which when we look at our temporal visualization, there was military service here, but it was before 2001. And the next military service is indeed on the 14th of January 2021. In the same way, we could do something like this, where we'll be using something similar. The last non-military service equals, go to the rule assistant, and we'll use when last. Remember that when last starts at the latest date, it starts at the date given and goes backwards up in time. So I'll say starting today, and that'll mean heading backwards in time, and we'll say does not indicate military service. So I'm using the negative of my Boolean. Up. And we'll go along and refresh our debugger. And we'll see that according to temporal visualization, you had your last military service began on 2021-0114, which means the last date when you weren't in military service, starting today, heading that way, is going to be the 13th. So the last known day before you return to military service. So when last and when next are great for pulling data out of chronologies, and both of them are able to leverage this concept of a neat temporal Boolean allowing us to quickly identify scenarios that are interesting to us. So that was cool. And in a sense, that was kind of part one of now what do I do? What else can I do? You can probably get the hang of this is we have functions for finding stuff, and we also have functions for counting things. But we have functions that essentially look through the chronology and will find something. So you can see on the left-hand side, I've got the number of changes in circumstances equals interval count distinct starting in 1996 going to the current date using one of my temporal attributes. So that would provide me with the number of changes in circumstance. So two changes in circumstance or whatever. The number of non-military activities is just a slightly different version in that it allows me to have a Boolean condition attached to the count. So I can count the number of non-military activities, which would probably be one by the looks of my data. Leveraging these functions and the others that I've shown you is proof of how easy it is to extract information from a temporal chronology, um, as opposed to trying to mess around with entity and instance data. So let's go to a second example and look at some other interesting functions. So a little bit less preamble this time. There's a entity called the bank statement line, and the bank statement line, I'm sure you know what a bank statement is. You have amounts of money, you have a running balance, you have a date, and you have a transaction type. But it doesn't really matter. Let's just say you want to convert this into temporal format. So that's how you would do it. The bank balance in temporal format equals temporal from start date followed by the relationship, followed by the date, followed by the piece of information that you're interested in. So this is no different than the previous examples I gave you. Now that we have this attribute, what could we do? Well, we could find out the highest balance. You could say the customer's highest balance equals interval maximum from the earliest date known in the statements to the latest date in the statements, and using the temporal attribute as our starting point. You can go even more clever and use interval consecutive days, and there are a whole bunch of functions like this one, not just consecutive days, but has the customer had a balance of at least $100 for 10 days? Well, interval consecutive days, starting at the start, ending at the end. Um, 10 is the period of time, and the bank balance in temporal format is greater than or equal to 100. It couldn't be simpler. Uh, Once you have your temporal attribute, there's a whole batch of functions. So I showed you when next and when last. We've talked about interval maximum, interval minimum. Now we're looking at interval consecutive days. We're also looking at interval count in the previous slide. You can notice that many of these functions are essentially temporal versions of functions that you probably already know, like instance count if, instance maximum if. So if you know there's an entity function, there's probably a temporal attribute function that does something similar. So these are all functions for identifying interesting events in your chronology. So we're getting into a stage now where things are pretty cool and we are able to create a temporal attribute and extract information from it. Let's take it a little bit further and look at another interesting usage of temporal reasoning. Let's start with a very simple basic rule. I've just slightly renamed the one that we used at the beginning. The paid benefit amount equals the number of children multiplied by the benefit rate at n minus 1. We need to clarify a couple of things. One, the benefit rate changes regularly. So the benefit rate changes once a month or once a year or once a quarter. And the benefit payment, so the result of this calculation, is made according to the benefit rate the month prior to the payment date. So if you get paid in November, the benefit rate that will be used is actually the rate that was set in October. So your benefit paid is based on the n minus 1 benefit rate. This is quite a common thing you see in some organizations where setting a new benefit rate doesn't become applicable immediately for customers. We set an interest rate in January and it becomes applicable to the balance of your account in February, that sort of thing, if you're a credit card holder. So we want to be able to take that into account in our rule. And we also want to know how much benefit has been paid so far this year or in a particular period of time. That's another common one. Yeah, I want to read the chronology and count up how much things, how much money, how much benefit, how much bank balance is being consumed. So what a surprise. There's a function for calculating the amount of benefit paid called interval daily sum. So the first part, or rather the last part of that slide, is easily answered with a function called interval daily sum. If you know the daily amount, you can then calculate how much has been paid over a period of time. The second part, and this is the interesting part, is we're going to use a function called temporal days since to create a calendar, to create a temporal calendar, and to use it as a reference point. In our case, we're going to create a calendar. We're going to create a benefit rate for January, February, March, whenever, and we're going to use a calendar to work out on a given date, 1st of January, what was the benefit rate a month previously, so the 1st of December, because that's what we want to do. If it's sounding confusing, don't worry, it won't do when you see the video because it's something that actually makes a lot of sense in many organizations. It's a useful demonstration of interval daily sum as well as temporal days since. Here we go.
In this video, we're going to look at two more functions of temporal attributes in order to solve the problem that was highlighted in the previous slide. Let's put down on paper the things that we already can talk about. So the paid benefit amount, what we want to do is the number of children multiplied by the benefit rate at n minus 1. So the previous month, if we will. We also want to be able to calculate the amount of benefit paid since the start of 2020. Let's do that. And we know that we need to do that. So there is a function we can use, is interval daily sum, and we'll say starting on the 1st of January 2020, running up to today. Of course, it could be up to any date. And we're going to introduce the paid benefit amount. So interval daily sum is a great way of taking a daily amount and then calculating an overall total for it. But now we have the challenge of identifying the benefit that is payable on a given day, because the benefit rate is a simple attribute, but we need the benefit rate at n minus 1. So we're going to do this in several parts. We're going to create a calendar, or a chronology, if you will. And we're going to use add days, which I'm sure you've seen before. This is not a temporal function, just a standard function. And we're going to say add on the number of days since the 1st of January up to the current date. And now let's go and have a look in the debugger at what happens with that data. I'll reset. And the calendar for benefit, which is the rule we've just created, has created a chronology, a calendar running from the 1st of January 2020 up to today. And of course, it will continue on because we said up to the current date. So this calendar for benefit, which is essentially just a daily calendar, is going to be the backbone of the next part of our calculation. Before we go any further, though, what we will do is we'll add the attributes that we need. So I've added, of course, the benefit rate at n minus 1. the number of children, the paid benefit amount. These were all added because of the rules. But I'm also going to add the benefit rate, because in order to calculate the benefit rate 1 month ago, we still need to have the benefit rate. So if I was to debug right now and go and look at the benefit rate, of course, is going to be temporal, and we'll say that the benefit rate changes, the benefit rate changes, let's say 4 times. No, 3 times will do. And we'll say that its first declaration would be on, I don't know, let's go right back and go as far as December 2019. You've probably worked out why I've chosen December 2019, because December 2019 is 1 month before the beginning of 2020, and we need to be able to calculate for 2020 starting in January. So I'm going to say that the rate as of that date was 15 currency units, whatever it is. Then we'll say that the rate changed in June 15th of 2020 and went to 17.5. And then finally, we'll say that there was another change in 2020. Whoops, that won't get me very far. 2020 in November. And we'll say that the rate changed on the 1st of November and went to 18. So now we have a benefit rate that is temporal. So the benefit rate in December of 2019 was 15. The benefit rate then changed the next time. It was 15 all the way through January, February, March, April, May, and changed on the 15th of June and went, not 175, excuse me, 17.5, that's a better number, and changed to 17.5 on the 15th of June, and then it changed to 18 on the 1st of November. So you can probably see where I'm going with this is that if you were paid benefit in November, you would actually should have been calculated on the rate 17.5, because you're only calculating benefit on the rate that was valid for the previous month. Okay, so now we have our basic set of information available to us in terms of attributes. We've got our basic need is to calculate the paid benefit amount, and our second basic need is to calculate the amount of benefit that's been paid so far. Finally, therefore, we need to add the benefit rate at n-1 equals. So we're now going to calculate the correct rate. And to do this, we will use a temporal function, value at. So you know what we want to try and do is we want to try and pick the value at today's date minus 1 month. We want to be able to get the rate a month ago. And to do that, we will use add month. And we will look up our calendar. And we will subtract 1 month. So that we'll go into our calendar for benefit, and if today's date is the 3rd of July, we will go and find the 3rd of June. And then we will pick up the benefit rate that was valid on the 3rd of June. So the benefit rate for n-1 will actually be the benefit rate on the date minus 1 month. If we now go to the debugger, we'll refresh the screen, and we'll say the number of children, which is, of course, the item which we hadn't filled in so far. We'll say that starting at 0, and then let's make 2 changes. We'll say that your first child happy event arrived in February of 2020, and the second child arrived in November 2020. There we go. So it means that, first of all, we are able to see the benefit rates. So the starting rate was 15, and then the 15th of July, the rate changed to, I still got 175. I need to go and correct that. My apologies, it's not 175. It's because of the formatting on my keyboard. I'll get there in the end, 17.5. That's better. So we'll go back and look at the benefit rate and say, well, yeah, it was 15 all the way through to the 15th of July, which is 1 month after the actual rate change. And it went to 17.5. And then 1 month after the rate change on the 1st of November, it went to 18. So our benefit rate at N-1 is functioning correctly, which means we are then able to calculate the paid benefit amount. So in the first part of the year, you didn't get anything because you didn't have any children. Then you picked up on the original N-1 rate and you moved to the new N-1 rate on the 15th of July. And you moved to the new N-1 rate on the 20th of November because you had a second child. And then, of course, in the final month of the year, you benefited from the final increase in the benefit rate. And the total benefit paid since the start of this is 6,684 since the start of 2020. So what started out as a fairly complex calculation in reality turned out to be quite simple based on two key points in this video. Number one, the ability to create essentially a calendar. Now, I created a calendar using temporal days since because I wanted a daily calendar, but you can see that there are temporal weeks and months since, and also using interval daily sum to calculate a value over a period of days. So if I wanted to know how much had been paid to the person based on this benefit amount being a daily amount, interval daily sum calculated it for me.
So hopefully all those videos have really shown to us how powerful temporal reasoning is and how it's easy to start simple and build it into something more complex. Now let's look at the last 2 points in the video. First of all, how to display temporal data. Well, uh, the simple answer is you can't natively display temporal data. There is no control type that lets you display it in an interview. So you might want to display it in a different way, where you would need to convert it into entity instances, for example. You'd need to convert it back out of temporal data, back into entity instances, and then you could display it either, as you can see on the left-hand side, using an explanation, which is why it says show details, or you could use a JavaScript extension, which you can see on the far left-hand side. Is you could build your own JavaScript extension to display it in a way that is appropriate for chronological data. But basically, it is not possible to display temporal data natively in an interview other than using your own code. Since you can't actually display it and you can't actually collect it, there is no interview control for collecting temporal data. You can simply ask the user to enter the data using an entity collect. The entity collect, so just ask them to enter the data normally. Of course, in many times the data is actually loaded from another application, not just by a user, but essentially an entity collect is your starting point. If you've collected data using a entity collect, you know how to use temporal from start date, temporal from end date, and temporal from range to convert it into a temporal attribute. But in this module, we've spoken, therefore, at length about how to transform entity instances into temporal data. But what about the reverse? Since I've just told you that in order to display temporal data, you need to have it in entity format. So if you have spent time building a chronology, how can you deconstruct it and convert it into entity instances, which you could then display using an entity container, or you could then aggregate in some way, or you could simply send it back to an external application. The technique is quite straightforward and is documented with an example online at this link in the online help. Here is a summary of how you do it. Starting at the bottom, you can see on the bottom I have a temporal attribute to be converted. So that's my temporal data. And you can also see on the bottom on the left-hand side, I have an entity with some instances. So I'm going to convert the temporal data, the temporal attribute, back into entity instances. You do it in several steps. The first thing is you need to create a couple of extra relationships. That's the heading upwards. That's the second screenshot. You'll notice that as well as the standard containment relationship, I have two other relationships, one called the first bank statement line and another one called the next bank statement line. The first bank statement line is a one-to-one with global because there can only ever be one first bank statement line. And the next bank statement line is a one-to-many between a bank statement and another banks and other bank statements. Because when you're calculating, you're looping through the data that you have, you need to be able to find the next bank statement line. Now looking at the rules, the first part should be fairly obvious. The initial value just looks at the temporal attribute that you want to be converted and finds the earliest value. So that's going to be the first line. That's going to be the first entity instance. And then the first change date is going to be when next, starting at the earliest, when the temporal attribute value has changed. So in my case, if my temporal attribute has 5 values, the initial value, of course, will be the first value. The first change date will be the first date at which that value changes. The third line creates the first entity instance. It's an exists, so it infers the existence of the first bank statement line based on that first change date. Of course, if there is no first change date, for example, the attribute never changes or the attribute isn't temporal, then you won't get anything. Now that we've created the first line, so the first bank statement line on January 14th, we need to now move forward from January the 14th, looking for the next time that the bank statement value changed. So the bank statement line's next date goes ahead and looks in the temporal attribute, looking for the next change point, and says, when does the value change next time? And if it finds it, it says, okay, then I need to create another entity instance based on the fact that I've found another line. And it repeats that, going through all the change points of the temporal attribute until it's created, in my case, 1, 2, 3 entity instances. Finally, you need to make sure that the value of each of those entity instances is populated by grabbing the value of each of the temporal change points and placing them in the bank statement lines entity. Very well documented, very similar to a lot of the what I call the controlled looping scenarios that we do in Intelligent Advisor, but here used to convert temporal data back into entity instances. So, what can we conclude from the time we've spent together today? We can conclude that temporal reasoning is a core part of Intelligent Advisor. In fact, everything is temporal. But using the feature requires a reason. You need to think about, do I care about changes that are affecting my rules? Is my data going to be temporal? Is my customer going to be giving me data that changes over time? You don't just use temporal reasoning because it's cool. You use it because you have a need of that kind of functionality. There are hundreds of projects out there that don't use it, and there are hundreds of projects out there that do use it because they need to use it. There are lots of examples, both on the Oracle documentation website and on intelligentadvisor.com. And the link you can see here is a link to a 5-part series that we wrote last year about getting to grips with temporal reasoning. I hope you enjoyed this module today. I enjoyed spending time with you, and I look forward to seeing you again on intelligentadvisor.com.